Aloha. So this is your solution guide for problem number 4. So here we're trying to buy shrubs and daylilies at $3 and $4 each, and our one restriction is we only have a $60 gift card. Our other restriction is that we only have 40 cubic feet of space inside of our vehicle, and shrubs take up 4 cubic feet, and the daily take up 2 cubic feet. So our main mission is to spend our money and get the most plants home in one trip. That's what we want to do. So it's a little bit different of a setup than before because we're not worrying about like maximizing your profit. And we'll see that later on. So let's start by reading the problem. Did that, declare variables, set up our inequality, and then carry on. So first thing, what are our variables that we're looking for? We have two variables. We're talking about the number of shrubs and daylilies. So let's let x be the number of shrubs you buy, and y is the number of daylilies you buy. So those are two variables that we're looking for. Now we're going to talk about our restrictions. So those inequalities are going to be set up by restrictions. And here for our restrictions, the first one is we only have a $60 gift card. So the amount of money we spend, so the first one is a cost restriction. The cost has to be less than $60. The second one is a space restriction. So here we have only 40 cubic feet inside of our vehicle. So we got to be less than or equal to 40 cubic feet and less than or equal to $60 for that to combined. So now when you buy something, you want to multiply the price by the number that you got. Well, the shrubs are $3 each, and the amount that we're getting is what we call x. So when you multiply 3 times x, you're spending that much money on shrubs. And the dailies are $4 each, so when you multiply the y value, the number of dailies you buy, times 4, the cost per one, you're going to get a grand total cost of how much you're spending on daylilies. So you add up the cost of both of them to get a cumulative sum total of hopefully less than or equal to $60. Similarly, for the space, the shrubs take up 4 cubic feet and the daylilies take up 2 cubic feet. So you need both of those inequalities here as restrictions to set those inequalities up. If we look at our graph here, this is already done for us, and you can kind of see that each of these represent those scenarios by looking at the x and y intercepts. So for example, if we look at this first equation, if I only wanted, or inequality, if I only wanted to buy shrubs, excuse me, and I didn't want to buy any of the daylilies, well, if the shrubs are $3 each and I got 60 of them, I could buy 20 shrubs. Or if you reverse that and you only want to buy daylilies, you could buy 15 daylilies. 4 times 15 is how I get to 60. So those 2 points right here on this green inequality connected through the line and all of the points that are shaded below it, that green inequality represents all of the things that are going to keep your cost under $60. Whereas the space inequality is given by this red one. Right here, if I only want to bring home shrubs, since shrubs take up 4 cubic feet and I only have 40, I could only bring home 10 shrubs. So that's referring to this point right here. 10 shrubs and no daylilies. Otherwise, if I only want to bring daylilies, this is referring to that value up there. No shrubs, 20 daylilies, each of them are 2 cubic feet, so then 20 times 2 is 40. So that red one is for the space, the green one is for the cost. So this one's a little bit different because we're not trying to maximize a profit or anything. What we're trying to maximize is the amount that we're bringing home. So if you want to figure out how much you're bringing home, that amount is just, you add up how many you're bringing home, the number of shrubs and the number of daylilies. And we want to maximize that. So we want that to be the largest thing that we can have. Now our critical points, again, are all of the points that are in the overlapping region of both shaded regions. So it's in this, maybe I'll highlight it here, it's in this region right here. So this is where all of the points are overlapping from both shaded regions. So every single thing in here represents a solution. Now we could just buy 1 shrub and 1 daylily, but that's not spending the most of our money and it's not bringing the most amount of items that we can come home. I mean, you could buy 3 shrubs and 1 daylily. So again, as you are working for your critical points, you're trying to get as far away from 0 as you can and stretching your boundaries. So stretching your boundary in the middle goes to there, stretching your boundary over here goes to there, and this one stretches up over here. So your 3 critical points are 0, 15, 4, 12, and 10, 0. Now these other points that I have plotted up here, the 0, 20, and the 20, 0, they are important points, but they're not critical points because they're not part of our solution set. So down here we can just write these out, 0, 15, 4, 12, and 10, 0. Now for the amount equation, you're just adding these all up. So if you take 0 plus 15, you're going to get 15 of those plants home. Here, if you add 4 plus 12, you're going to get 16. Looks like a 7, there we go. And here, if you just add 10 and 0, you're going to get 10. Whoops, 10. So clearly the one that will give you the most amount of plants home is going to be that, that middle point right there at 412. So now again, just kind of recap this. If you're buying 4 shrubs and they're $3 each, 4 shrubs times $3 is 12 bucks. And if you're buying 12 daylilies and those cost $4 each, that's 48 bucks. So altogether, you're spending your full $60 gift card. As far as cubic space goes, cubic feet, if you buy 4 of them and they take up 4 of them, that's 16 cubic feet of space. And if you're buying 12 daylilies and they take up 2, that's 24 cubic feet. And if you add that up, you're going to get a grand total of 40 cubic feet. So this spot right here is fully maximizing your space and your amount of money.